So now we have done contextual DLP. It is time to talk about what happens when you are ready to do the content inspections with data loss prevention features and capabilities. So the first feature that is very popular within data loss prevention is policies based on file types. So out of the box, Zscaler's DLP supports hundreds of file types, and you can simply pick and choose a specific file type and you can protect that data. Again, the use case here is if any of my users are uploading Office documents to an application called pdfconverter.com, I want to block it. And in this case, you go to our policy engine, you select a specific file type, and then for that specific file type and file size, you allow or block all applications, you allow or block different actions and activities. Behind the scene, when we are enforcing policy based on file type, we are not just simply looking at the file extension. If we did that, then it's going to be very easy for users, malicious users, to bypass by simply changing the file extension. Instead, we do 3 levels of inspection. First, we look at some of the early bytes that we call magic bytes. Then we will look at the MIME type, and then we will look at the file extension. And then this 3 levels of inspection gives us a lot of confidence that we are not generating any false positive. So again, the file type based data loss prevention is very popular, simple policy. You can combine a policy where you are not only looking at the file type, but you are utilizing our Cloud App Control to enforce a granular policy based on that specific cloud applications or activity. All right, so now once you did some file type control, let's now look at how do we look at the content and do deep content inspection with different type of DLP bells and whistles. So the first one that comes, which is the predefined dictionary. So out of the box, the Zscaler DLP engine, we provide hundreds of predefined classifiers to identify PCI data, PII data, PHI data. Of course, within the PCI industry, credit card number is a very popular dictionary. If you are trying to protect PII data, it is, perhaps someone's social security number in the US, but UK tax ID number for UK users, or Canadian SIN numbers, or different countries, they have different PII IDs. So we support hundreds of them today. On the PHI world, we are looking at ICD-10 codes, CPT codes, different medical dictionaries and things like that. Now, a lot of these predefined dictionaries we built based on standard regex and PCRE engine, but many of these dictionaries we have also utilized AI and ML. For example, we have a dictionary that identifies source code. You cannot write a regex to identify source code. So we had to lean on AI and ML. Same thing for financial statements, profanity, adult languages, and so on. Beside predefined dictionaries, we also offer a custom dictionary engine. Our customers can build their own dictionary based on different phrases, keywords, and patterns and regular expressions. Perhaps you are trying to protect documents that has a header and footer called company confidential or internal use only. So you can definitely leverage our custom dictionaries for that. Now, the way the DLP policy works is that you take these predefined dictionaries and custom dictionaries, you build a DLP engine, perhaps by combining both predefined dictionaries and custom dictionaries using different Boolean logics like and, or, not. And then once you build these DLP engines, then you take those engines and apply that to a policy, right? So an example would be, let's take Zscaler's credit card dictionary, any document that has 50 credit card numbers, I'm interested to know, and combine that with another predefined dictionary called employee's first name, and then combine these two dictionaries with a custom dictionary that says company confidential. So essentially, you have combined a predefined dictionary with custom dictionary with different Boolean logics. You build that DLP engine, and then now you take that engine and apply that engine to a policy. The predefined dictionaries, custom dictionaries, the engines, those are basic building blocks for DLP. Now, many large enterprise customers, majors, they go above and beyond just building DLP policies using dictionaries and engine. Exact data match is a very popular feature within our existing install base. Here, the customers want us to match their exact data, and then based on their exact data, they want us to take different actions. So here, we are not triggering a DLP policy because we saw a generic credit card number, but instead, we are looking at a very specific credit card number that belongs to that organization. So EDM was designed to learn from your structured data. Let's say you have a very large database and you want to protect the data, or let's say you have a large CSV file where you have 200 million rows, 10 different columns. Each row is representing, let's say, one of your employees' PII info. And their first name, their last name, their credit card number, their social security number, their address, all of that structured data can be fed to Zscaler's EDM engine. And then EDM engine will learn from your own data. And then once the learning happens, then the EDM engine is looking at all cloud transactions and matching your exact data and then triggering different type of actions. The question is, how do you feed that data? We never ask our customers to upload their sensitive data in our cloud environment. Instead, we give our customers an on-prem VM. That on-prem VM is basically the index tool for EDM. So you would take that on-prem VM, it's essentially a VMware image, you would deploy it to your on-prem locations, and then you start feeding your data to this on-prem VM. By the way, nobody from Zscaler has access to this on-prem VM because, again, this is a VMware image that you install, you deploy, and you control. When you feed your structured data to this on-prem VM, it doesn't have to be a manual process. You can automate that whole process. You can point your database to this on-prem VM, and then incrementally, the index tool will fetch your data and then index your data. Now, what we do is we take each one of these data element, we create a hash, and then there is a persistent connection between that index tool and our cloud. And then the index tool, as and when it's creating hash for each and every single data element, it basically pushes that hash to our cloud. So in our cloud, we don't store your exact data. All we are storing is a bunch of hash and tokens. And then once that indexing is done, let's say someone is trying to exfiltrate Jim Smith's personal data via email. In the email, we see Jim and Smith, we see his exact credit card number. We will do a hash-based lookup and we will hit the exact match. And because of that exact match, then we will take different actions. Okay, now let's talk about another popular feature that is widely adopted. IDM, index document matching. At the end of the day, it's basically document fingerprinting. Now, remember in the previous slide when I talked about EDM, EDM was designed to learn from your structured data. IDM is designed to learn from your unstructured data. Many organizations, they will say, we have a lot of sensitive data, but they are not in the database. They're not in CSV. We have crown jewels saved in Word documents, in PDF, and so on and so forth. So these are your unstructured data that you want to protect. In that case, the concept is very similar, like EDM. You deploy our index tool, and then you start feeding your unstructured data to this on-prem index tool. And we learn from these documents. We are learning from Office documents. We are learning from your PDF documents. Perhaps you have an empty forms. It could be your purchase orders. We can learn all these documents using IDM and document fingerprinting. When you build a policy, your policy can be extremely granular. So you can say, when you see a 25% match, then take this action. But if you see 75% match, take a more drastic action, right? So the difference between EDM and IDM, it's EDM was designed to protect your structured data, and using IDM, you can protect your unstructured data by fingerprinting and creating different type of granular policies.